what we're going to look at is the concept of completing the square to be able to, in fact, solve a quadratic formula. This is just another method, another tool, if you will, that will help you find a method and give you a choice to which one is going to work best for you. In the next couple of minutes, I would grab out your MJ and copy down what you can. This is actually out of your book from lesson 9.3. And it's a little bit difficult to copy down, but see if you can just catch the idea of it at first, and then I'll give an example that you can kind of follow along with. So the idea of completing the square, I'm going to use algebra tiles, which is what your book uses too. I think it makes the most sense when you think of a square. Then when you complete one, you think of making an entire square. For example, you have an equation that looks like x squared plus 4x equals -2. And we're going to solve it by completing the square. You'll notice that on one side of the equation, they took this section right here. We're going to talk about this format in just one moment, but at this point, what's inside the parentheses is on this side right here of the equal sign. We're not going to worry about this -2 at this point. We simply want to complete the square. You'll notice that there's some pieces missing with only that first section, the x squared and the 4x. What you'll see here then in the next slide is, if I can scroll down, oops, there we go, that what can fit right here, right here, right here, right here is that you can add 4 algebra tiles to complete, essentially, the square. So on the inside then, think of the squares that we make for factoring, is now this square is complete by adding the 4 tiles. Now mathematically, we know in an equation, if I add 4 to one side, what do we have to do to the other side? Absolutely, we're going to add 4 over there too. Here's what it looks like in algebra tiles. When you simplify, remember, these two end up zeroing out, and therefore we're left with 2 on the right side. Let's take a look. Where did they get this x plus 2 squared? Well, remember, they just rewrote what you have. Inside here is the sum. What we have up there, this is the sum as well in red. What we want to do now then is to write it as base times height, essentially factor it. There's my base, there's my height, and because they're both the same thing, it ends up being a square, which hence is x plus 2 squared. Scroll down a little bit further. In order to completely solve this now, what happens is if I take the square root of each side, so square root this side, square root this side, the left side just immediately gets rid of the square, so you're just left with the x plus 2. When you take the square root of a positive 2, remember, there's both the positive and the negative square root, and therefore, my last step, if I draw my wall, I'd have to subtract 2 from both sides, -2, and then we can write it as a -2 plus or minus the square root of 2. If you'd like, you can pause and they do a check right here to kind of see is that the right answer by plugging it back into the original equation, and you hopefully should end up with the same answer. Here's the official, here's one more example, sorry. So we're going to solve this one by completing the square. First off, my equation ends up being what I have here. I have an x squared plus 6x equals a -5. That's just what I have right here, an x squared, 6 x's, and 5 negatives. Well, in order to fill in the square here, I'm going to need 9 units. Bear with me. And all of these are going to be positive. Positive, positive. Okay, so algebraically, here's what just happened. is I ended up adding 9 positives to essentially complete my square. Okay, at this point, I now have x squared plus 6x plus 9 plus 6x plus 9, and all of this equals a negative 5 plus 9 gives me a positive 4. I'm going to rewrite this as a factor, and if we come over back up here, I know this is an x, I know this is going to be a 3, and this is going to be an x, and this is also a 3, and therefore my factoring becomes x plus 3 times x plus 3, which is squared, equals 4. Now, if you wanted to take this piece right here and draw your rectangle without the tiles and actually draw it out like we had before, then that would be a 9, and do your diamond problem, you'll end up with the same answer as well. Lastly, I'm going to take the square root then of both sides, square root, square root. This is the example I was talking about. That would be fairly easy to copy into your book. I'm left with just x plus 3 is equal to, don't forget, positive and negative 2. And give myself a little bit of room. Last step, I'm going to subtract 3, minus 3, minus 3, and my official answer ends up being x is equal to either 2 minus 3 or x is equal to a negative 2 minus 3 gives me a negative 1 or a negative 5. Now, using the tiles is nice and neat. Obviously, you will always have the tiles, so there must be an equation, and there is an equation. Let me show you what that looks like. It says right here, another method for solving a quadratic equation is to complete the square. In this method, a constant c is added to the expression x squared plus bx so that it completes into x squared plus bx plus c is a perfect square trinomial. So here it is, completing the square. Step 1, find 1/2 of b. Now first off, you'll notice this equation right here is not in the same form over on this side. We must complete first, or set it up so that we can complete the square. That means I'm going to switch this 3 over to the other side before I can even begin this process. So now I'm left with x squared plus 8x equals 20. Okay, now here we go. Step number 1. What is this number back here? I ended up having to add 9. We're trying to figure out how can we figure out this number without having to do tiles. How can we figure out this number without having to do tiles? So here's the equation. It says find 1/2 of b, which is the coefficient of x. So I need 1/2 of 8, which is 4. Step 2. I'm going to square the result from step 1. So I have a 4. I'm going to use a different color. 4, and then add the result to the original. So I'm going to add 4 squared to the original number. Now, obviously, if I add 4 squared to one side, I'm going to have to add the 4 squared to the other side. So I'm going to add 4 squared over here. Let's do what we have now. Rewrite it as a combo. X squared plus 8x plus 16 is equal to 20 plus 16 gives me 36. Next step then is I'm going to factor this section right here, which means on the side you can draw your rectangle, put your x squared, your 16, make your diamond problem. You end up with, hopefully it's a perfect square, that's the whole idea, x plus 4 squared is equal to 36. So this equation right here really just tells you how to do it. Take half of b and then you square it. That's where this green section came from. The rest of it is similar to the other problems that we've done. And just to complete it, we're going to take the square root of this side, square root of this side, x plus 4 equals a positive or a negative 6. Whoops, sorry about that, 6. And finally, subtract 4. Subtract 4, you're going to end up with two different answers. X is either going to equal a positive 6 minus 4, or x equals a negative 6 minus 4. And therefore, we end up with a negative 10, or x equals 2. And those are your two answers. Again, these are from lesson 9.3 in your book if you'd like to look for more examples.